Our last concept for 1.1 is what we call least common multiple, or a lot of times I'll refer to it as the LCM. So what we're looking for by least, we mean the smallest number that both, like our first example here, 12 and 18 will divide into. So that's why it's called the least common multiple. One way to do it is by simply listing the multiples. So let's take 12. Let's take 12 and we'll list some multiples. 24, 36, 48, 60, and it keeps going, and I can keep going if I have to, but I'm kind of getting tired of doing it. So, but those are the first 5 multiples of 12. Okay, now let's do 18. 18, 36, 54, but I'm going to stop because I already found a common multiple. What am I doing to get these multiples? Well, with 18, I'm just adding 18. 18 times 1, and I add another 18, or 2 times 18, 36, 3 times 18, 54, and on we go. But right here, I have found the first multiple that is in both lists, and so that's the least common multiple. So the LCM for 12 and 18 is 36. Now if we had 2 different numbers, it would be different, but that would be what we would call the least common multiple for 12 and 18. Okay, so example 9 here. Find the least common multiple by listing multiples. And the 2 numbers they give us are 9 and 12. So you start with 9, and then you're just going to list multiples of 9. And then how far do you go? Well, I don't really know. I'll do more if I have to, but I think I'm going to get one. So, and you really don't always know. It depends on the numbers that you're given. But those are multiples of 9. Now we'll do 12. 12, we could just reuse what we did up above. And there, I can stop because I found the common multiple. So the least common multiple is 36 here. Okay. Another way to do these is to use prime factors. So what we can do is we can take 12 and we can break it down into its prime factors. Now, we did that on, I think, the last video, but I'm going to do it over here. 12 is 3 times 4, 3 is prime, and 4 is 2 times 2. Okay, so here's how I'm going to write the prime factorization for 12 then. It's 2 times 2, and then times, I'll put a little dot in there, 3. Now, we call this the box method sometimes. They'll put a box, they usually put the box like this. Okay, so there's 12, and there's the factors that make up, the prime factors that make up 12. 2 times 2 and times 3. So you got 2 2's and a 3. That's what gets you a 12. Now we do the same thing for 18. So 18 is 2 times 9, and 9 is 3 times 3. So for 18, I have 1 factor of 2 and 2 factors of 3. And so it looks like that, the prime factorization for, I can put a dot in here, but the box is just a tool to work with these, to try to find the prime or the LCM. So what you do is you look in a column, and the thing about the least common multiple is you have to have a representation for 12, and you have to have a representation for 18, and you don't want any more factors than are necessary. So for the 12, you're going to need 2 2's. Because if you don't have 2 2's, you're not going to find a 12 in the number. You're not going to be able to divide it by 12. So I have to have at least 2 2's. I don't have to have 3 2's, because 1 2 is enough for 18. You know, it's like you have 2 kids and one of them wants to go to 2 movies and one of them wants to go to 1 movie, as long as they're the same movies. Anyway, to satisfy both of them, you just have to go to 2 movies. You don't have to go to all 3, you know. I don't know, that was not a good example. Okay, now we do the same thing, we look at the 3's. Well, 12 has 1 3, But 18 has 2 3s, so you're going to have 2 3s, otherwise you're not going to be able to get 18 in there. Now, so that looks like 33. Okay, therefore, 2 times 2 times 3 times 3, that's going to be the LCM. So the LCM, in this case, is going to be 4 times 9, which is 36, which I think we knew that before, but that's where you get it. You get the 4 here, and the 9 here. 4 times 9 is 36. Okay, now what I want to show you, though, is it's kind of visual here, so I'll try to do this, but here is the 12. So, right, 12 is 2 times 2 times 3. So if I need to, make 12 into a 36, I know I just need another factor of 3. Here is the 18. It's 3 times 3 times 2. So if I wanted 18 to be 36, I just have to multiply it by 2. That type of thing is very useful to work with those smaller numbers, especially when we get into numbers that are larger and a little bit harder to work with. We break it down into its primes, and then we can look and see, okay, well, how many 2's are there? How many 3's are there? How many 5's are there? Okay, so hopefully that helps. So we have one more example. Nope, 2 more examples. Find the LCM using prime factor method. Okay, so here we go. Here's 18, and I'm not going to redo it. I already did 18 once. It was 2 times 3 times 3. I kind of want to separate them so I don't overlap the factors. I want to like a column for 2's and a column for 3's, and I might have other factors as well. 24, well, what's 24? 4 times 6. 4 is 2 times 2. 6 is 2 times 3. So there's the prime factorization for 24. It's got a 2, 2, 2, and a 3. All right, so here comes the LCM time now. And this might be easier than listing a bunch of multiples, especially if it's a fairly big number. Okay, I'm going to have the most number of times it appears in the column. So I need 3 2's, and I'm going to need 2 3's. And that's going to be 8 times 9, which is 72. So there's the LCM, 72. All right, you can think about that. 18 times something is 72. You could divide that out on a calculator if you wanted to. It's 4. It's going to be 4. And same thing with the 24. Okay, let's go to another example. Yeah, so we've got 21 and 28. 21 and 28. 21 I know is 3 times 7. Now I'm going to put the 3 in the middle because I know I'm going to have a column for 2's. I don't always have a column for 2's, but I know the 28 is going to have a 2. So 21 is 3 times 7, and 3 is prime, 7 is prime. So that's prime factorization. 28, let's see, what's that? 4 times 7? Oh, I'm glad we're doing this example. Okay, so it's going to bring something up. So I have 2 times 2 times 7 for 28. You can always check this by multiplying it back together, and you should get 28. Okay, so I have 2 2's and the 7. Okay. I didn't have any 3's in the 28, but that's okay. So now here comes the LCM. How many 2's am I going to need? I'm going to have 2 2's. I'm going to have those 2's. The fact that 21 doesn't have any 2's doesn't matter. I take the most number of times it appears. So there are 2 2's in the 28. I got to have 2 2's. I've got to have a 3 because otherwise the 21 is not going to be happy if I don't have a 3. How many 7's do I need? I just need the 1 7. Okay? 1 7 is good enough for 21 and it's good enough for 28. You don't want the number, you don't want your LCM to be any bigger than is necessary because it's the least common multiple. All right, and then I have to multiply these together. So it's 21 times 4. What's that, 84? Okay.